I'm the Research Director at Maravedis-Rethink, and I'm your host for today. Today, Maravedis-Rethink will run the webinar and share some of our latest research findings from our three leading research services. That's MOSA, Mobile Operator Strategy Analysis, the Backhaul Service, and the RAN Service. We're also delighted to welcome our guest speaker today from AT&T, Jim Parker, who's Senior Manager of AT&T's Antenna Group, and therefore a central figure in the deployment of small cells in the USA. AT&T has one of the highest profile programs, as many of you will be very aware, for rolling out small cells as part of a cutting-edge strategy for LTE and heterogeneous networks. It has been particularly active in driving integrated small cells, which include Wi-Fi. We're very happy then that Jim will share some of the experiences of deploying a new architecture in one of the world's most competitive LTE markets. Before we start, we would like to run a poll to find out a little more about you, our audience, today. I'm going to ask Adeline, and if you would, when you see the poll, if you would just quickly click on the right category.
The poll is in progress. Seems to be 2 more seconds for people to get a chance to respond.
Yes, we like to do these polls. It gives us a snapshot of the mix of the audience, which does vary quite a lot from webinar to webinar. And as you'll see, we're going to do a series of polls through the event today to get your views on various topics and to make the session a little more interactive. So we appreciate your participation in that.
Okay, so the results of the poll are out, and we have of course, a majority here of hardware and software vendors, but also a big participation of the consulting, analysts, and press community, followed by the service providers who I'm sure are keen to learn from AT&T deployment experience. So I'm closing the poll now. Thank you.
Great, thank you. A good mix there, as we expected for a high-profile speaker like this. As I say, that's our agenda for today. There'll be some key findings from us at Maravedis-Rethink. Adeline will offer a few highlights of our services, and then, of course, we'll go on to AT&T's presentation by Jim Parker. And there'll be time for Q&A at the end. That's the most important part on this housekeeping slide. The slide shows you the main points of how to use the system, but most importantly, you can submit questions and review answers in the questions box as part of the dialogue panel that you'll see in front of you. Please feel free to type questions at any time that they occur to you through the presentation, and there will also be a short time after Jim's presentation to add questions. We will try to answer as many as we can, or to take a summary if a question is being commonly asked. A couple of frequently asked questions. The slides will be available for purchase from Maravedis-Rethink's store after the webinar, as will the recording. The event is being recorded. All attendees will be sent a link and information about those materials. And for more information about what we discussed today and our research services, please visit our website, which is www.maravedis-bwa.com. You'll see those details again later. Just before I share some highlights of our recent research at Maravedis-Rethink, we'd like to conduct another poll. This is the first of 3 that we're going to do covering small cell topics to get some audience feedback and get your views on some of the key subjects that we hope to discuss today. The first one we're going to look at is very topical, I think, to our session today, and that's small cell backhaul, particularly the spectrum that will be used to backhaul metro cells, in other words, public access small cells, when they're deployed outdoors. And we're particularly interested, because of our speaker today, in the North America region. So we're seeing the poll, people answering now. Just give a short while to get the results on this. It's one of the most contentious issues that we find in our research, and obviously, as we'll touch on later, still a lot of uncertainty about the various backhaul options for the small cells, but I think results are just coming in in now. I guess the good thing is there are a lot of options in terms of spectrum and emerging technologies using those, but that can also create a lot of confusion, and some of the technologies, of course, rather immature at this stage.
Okay, I'm closing the poll now and sharing the results.
Great. Interestingly, there we're seeing a very broad split over the categories. There's a fairly small lead for point-to-point microwave in the 6 to 42 gig spectrum, fairly conventional, but closely followed by the sub-6 gigahertz options and by point-to-multipoint microwave, which we've certainly seen in recent research in the backhaul service. It's a fast-growing option in terms of operator interest. So I hope that's a useful highlight, and it may feed into some of the later points that Jim and I are looking over. But for now, just going to share some very top-level highlights from the most recent research that we've been doing. The 3 services that Madeleine will tell you more about in a minute are all based on in-depth research with the top 100 4G operators around the world, operators who are either deploying 4G or have got firm plans to do so. And we focus on their infrastructure plans down to a lot of detail. And today, of course, we'll look at the small cell side because of the topic, but we also look at the macro layer and many other technologies. Some key points here. The public access small cells, despite all the profile of the cutting-edge operators, they still are a niche option for most carriers, certainly until well into next year. Then the prices and the standardization will start to enable the mass rollout. And we see by 2018 a dramatic rise in shipments of these metro cells. Our calculation is that it will reach nearly 3.4 million per year at that point. As a sort of companion to the small cell trend, we also see a big rise in interest in the cloud RAN. Of course, this is a macro issue, but many carriers who are doing small cells are also doing it in complement with the cloud RAN, where the base station functions are increasingly virtualized on Intel, usually Intel processors. We see about 30% of LTE carriers supporting that architecture commercially by 2017. So it's less mainstream than metro cells, which by that point will, will be in about 2/3 of operator deployments on a commercial basis. Other important technologies, increasing integration of the antenna and the radio, and new antenna technologies, including active antenna and MIMO, are very critical to making a cost-efficient and spectrally efficient 4G network. And of course, Wi-Fi. We do see a critical driver being the standards such as Hotspot 2 and next generation Hotspot, bringing Wi-Fi and cellular increasingly together. What milestones are needed, though, to achieve this critical mass for small cells? There's still a very big perceived need to address the gap between the early adopters, AT&T and others, who are really pushing out there and taking the risk on a fairly unproven technology. In the case of some of the operators we've seen in Asia, using very customized kit, so very advanced but very expensive. So how do we get from there to the mass market? We think there are 2 big catalysts on the infrastructure side: Wi-Fi integration and the coming of certain features of the LTE-Advanced sort of menu of technologies. So as you can see from the graph, we think that by 2018, of metro cells that deploy in that year, 75% will have Wi-Fi integrated. But there are still many other challenges. We believe key requirements will be the development of real system-on-chip platforms, more streamlined site processes to acquire sites and to make sure they are properly backhauled. Neutral host approaches will be very important in crowded urban areas. And further challenges which will not be quickly solved, we see roaming between different SOM platforms despite the standards. Operators telling us that's a major issue, major concern. Full interworking between the small cell layer and the macro layer, it's not at all simple. And of course backhaul. Backhaul emerges time and again as the biggest obstacle that that operators see to certainly to near-term wide-scale metrocell rollouts. And we can see from this slide some of the issues and dilemmas that carriers are facing. The usual one, equipment prices are high at the moment when you consider how many cells you need to backhaul, but they won't go down without volume investment, which means all the carriers having the confidence to get on board. The solutions they adopt need to be very much future-proof. We saw from that poll just how many options there are, and that there isn't a great deal of consensus yet about which technologies or spectrum will be the most popular, and therefore which solutions will gain scale. And there is still a lot of debate about whether metrocells complementary to the macro layer, or are they actually a substitute, and that deeply affects, of course, backhaul decisions and strategies. And finally, for me, I mentioned it just now, but as well as Wi-Fi being extremely important to make 4G networks more cost-efficient and more capacity-efficient, provide a seamless experience that goes across all kinds of technologies. We also do believe that the LTE-Advanced standards are going to play a key role in driving small cells from the cutting edge to the mass market. Of course, LTE-Advanced is a massive range of features and standards, some of which will be deployed heavily, some of which will remain niche. But it does provide some critical help with the small cells themselves, with interference issues, with interworking with the macro layer, and so on, and general spectral efficiency. So elements like EIC, standardized self-organizing networks will make it a lot easier for carriers to be confident in rolling out really big-scale metrocell networks as opposed to just small hot zones. So we believe that the parts of the LTE standard that directly improve small cell rollout and economics, as well as spectral efficiency, the two go together, of course, will be the ones that get the most carrier investment. You can see that in the graph, where in the early years, 2013 onwards, the early years of LTE adoption, the features that operators are really putting the money into are things like multiband carrier aggregation, EIC, advanced MIMO, these things that are allowing them to get more bang out of their spectrum buck always, and to make it more practical to deploy metrocells on a big basis. But mass uptake for any new standard still needs many things to happen. It needs a big device ecosystem, lots of interoperability testing, and most importantly, the confidence of the operators and the whole ecosystem. And I'm sure we'll hear a little in a moment from Jim, some perspective perhaps on some of those issues from an AT&T point of view. Before that, though, I'm going to hand over to Adelaine Feller, and he'll tell you a little more about the 3 research services on which these very brief highlights are based. So, and hopefully you'll find that information interesting. As a prelude to that, we're just running our next poll. It's open now, which is to try and gauge your familiarity with the services, which is obviously useful context for Adlin as he explains more about what we offer.
Thank you, Caroline, and good morning, everyone. I will be closing the poll now, sharing the results. It seems the majority are somewhat familiar with our services. And for those that are not familiar or never heard of, I will provide a brief overview of our research services. And next slide, please. So we are basically a wireless infrastructure analyst firm. We really focus heavily on the 3 aspects of the network, which is the radio access network, the backhaul, and the core. To do that, we have a number of services. I'll be providing an overview of the top 3. The first service is pretty self-descriptive and has to do with the RAN service. So we cover not only small cells, but also all aspects of the macro RAN, the variations, carrier Wi-Fi. And the service itself is an annual service. It has a number of deliverables that are listed here. And the whole essence of the research starts with interviews with operators. They're the primary source for the information. and they fit our model to estimate the number of cell sites and CapEx. And this information is cross-matched with interviews with vendors that we interview on a regular basis as well. And we also produce shipments and market size forecasts in terms of units, stars, and average selling pricing. The deliverables include 2 comprehensive reports in PDF and Excel for the quantitative side. We provide webinars for clients only where we explain the key findings and methodology and of the report and answer questions. The service also includes a number of research notes per year which have to do with important aspects of the RAN, whether it's carrier aggregation or cloud RAN or aspects that have a particular interest. And of course, there's all of this is served by analysts with interactive support and availability to answer a question. Moving on to the next service, backhaul.
Oh, sorry.
Previous slide, please.
Sorry.
Yes. So the backhaul service is pretty similar to the RAN service, except you focus on backhaul and focusing on backhaul from the perspective of other backhaul technologies, including wireline. And wireless is a focus service, but it is analyzed in the context of other alternative technologies. And so there we cover point-to-point, point-to-multipoint, and line of sight, and other emerging technologies. And again, here this is cross-match information between input from carriers as well as the vendors themselves. On top of that, I'd like to highlight the fact that we've done a lot of regulatory work. This is increasingly important for backhaul vendors to understand the emerging frequency bands that are made available for backhaul in light of available spectrum, for example, from WiMAX and etc. And so that's also a unique service that we provide. Moving on to the next slide. The final service, which is kind of the platform for all of the services we provide, is the mobile operator strategy analysis. And this is in the context of this service that we are organizing this webinar today. The service really focuses on input and interviews with top 100 mobile operators. And from that, information is extracted. We produce a number of outputs. So around those top 100 operators, we identify 10 important key areas of development in the wireless infrastructure. It's carrier aggregation, or as I mentioned earlier, cloud RAN. Understanding who are the champions in each important area. There are a number of leading operators, and these are analyzed in that context. This service also includes SWOT analysis of the operators and vendor ranking from the perspective of operators as opposed to shipments. And all of this translates into reliable forecast, both CapEx as well as qualitative aspects of deployments such as challenges or spectrum information. Deliverables include the actual infrastructure profiles, 100 of them, quarterly reports where we provide a summary of trends every quarter for those operators, as well as the quantitative hard data provided in Excel. There's a whole dedicated team in charge of maintaining and feeding the service, and that team is led by Cara and Gabriel. So if you need more information, next slide, you can provide, you can send me an email or visit Maravedis-Rethink.com. Thank you.
Thanks, Adeline. Before I hand over to Jim, we'd like to run 2 more quick polls back to back on, again, on small cell issues that I think we'll be touching on in the conversation from now. The first one is looking at timelines, and the second one at the form factor for, the technology, sorry, for the public access cells, and we really appreciate your views on this. The first one you're looking at now is timelines for deployment on a wide scale as opposed to the sort of cutting edge, almost experimental rollouts that we've probably seen so far. I think we're going to get quite a lot of consensus on this one by the look of it. Of course, this is the key issue for the whole ecosystem, is exactly when will metro surveillance become really mainstream and perhaps eventually commoditized, and therefore the prices will come right down. If our snapshot survey is correct, that timeline is going to be 2015 to 16. That's 2/3 of the audience believe that's the most likely timescale for mass market, and I have to say that chimes in really well with what we see talking to the operators on the ecosystem in our research services. And so finally, before our guest speaker, a second poll related, and this is looking at what type of public access small cells will be most commonly deployed, and I think the key issue here is will they be single mode or multi-mode, and how much will Wi-Fi be included. Again, it's an issue of much debate, and once you get into more detail, I think one of the contentious issues is when you say Wi-Fi integration, does that mean right down to chip level or in software? But for most operators, of course, the important thing is to have a seamless user experience, so that the customer is not aware of the changes. So polls closed there, and again, a lot of consensus there, with 62% believe that the most commonly deployed public access small cell will have cellular technology integrated with Wi-Fi, and the second after that will be a multi-mode 3G, 4G. So this, if we're right about this, it's going to be a very multi-mode world, which is a good lead-in to introducing our guest speaker, as AT&T, I know, has been a pioneer and an innovator in combining all kinds of different modes within its network, and perhaps that's one of the topics that we'll hear from. But very happy to welcome again Jim Parker, Senior Manager of the Antenna Solutions Group at AT&T Services. Thanks, Jim.
Well, thank you very much for the introduction. My name is Jim Parker. I am responsible for marketing AT&T's in-building wireless solutions. During this session, we'll address the catalyst or drivers behind deploying in-building wireless infrastructure. In order to meet our customers' insatiable demand for wireless voice and data services, AT&T is increasingly turning to neutral host distributed antenna systems, Wi-Fi, and small cells that provide solutions that augment the capabilities of our macro network. In addition to the network business drivers, we'll address the advantages of small cells, backhaul considerations, and then review the results of our recent small cell deployments. All of the mobile talking, texting, and surfing has not gone unnoticed. At AT&T, we have seen an explosive growth in the use of mobile data, with over 30,000% growth over the last 6 years. I mean, it's literally a data tsunami. Last year, AT&T spent nearly $20 billion on our wireline and wireless networks, and this year planned to invest nearly the same amount to accommodate our wireless and wireless data growth, while helping to ensure high-quality voice and data services for our customers. We're actually seeing similar growth in our Wi-Fi division. AT&T is the largest, or the nation's largest Wi-Fi provider, with more than 32,000 AT&T Wi-Fi hotspots in the United States. We had 20 million connections in 2008, as compared to 2.7 billion connections in 2012. This is over a 13,000% growth over the last 5 years. You know, to put this into perspective, it took a year to reach 20 million connections in 2008. The following year, in 2009, it took 6 months, and then 5 weeks in 2010. In 2012, we reached 20 million connections in just 4 days. So in addition to the Wi-Fi hotspots, AT&T has deployed hot zones in Chicago, San Francisco, Charlotte, Palo Alto, and New York City, to name a few. One of the other drivers behind the significant increase in wireless data traffic are users migrating from basic or limited feature phones to smartphones. Now nearly 75% of AT&T's postpaid customers use smartphones, which is up from 64% a year earlier. And as Cisco noted in their recent global mobile data traffic forecast, a typical smartphone user generates 50 times more data traffic than a basic cell phone. And in order to provide our customers with the best mobile broadband experience, AT&T established the Antenna Solutions Group that is chartered to extend the capabilities of our macro network to large public venues. In the venues where we deploy a neutral host distributed antenna system, once the venue is under contract, we turn over responsibility to the AT&T Towers Group to market the system to other wireless carriers. And AT&T Towers, of course, is the third largest owned tower portfolio in the U.S. with over 14,000 tower properties. So ASG, or the Antenna Solutions Group, deploys a wide range of technologies to include neutral host DAS, Wi-Fi, and small cells. Neutral host DAS and small cells provide a coverage and capacity solution for cellular voice and data traffic, where Wi-Fi primarily is a data-only solution that can be used to offload traffic from the macro network. In evaluating venues for potential deployment, ASG will identify the preferred solution. The macro BTS will continue to be the most efficient way to provide wireless service across America, with neutral host DAS systems being deployed in venues where a neutral host solution is required, and small cells offer operators a system that is potentially more cost-effective than the other solutions. In order to meet our customers' insatiable demand for wireless voice and data services, AT&T has announced Project Velocity IP, which is a $14 billion initiative to expand AT&T's wireline and wireless network. We are launching multiple technologies under this initiative to include voice over IP, or voice over LTE, which will allow us to take advantage of the all-IP-based LTE network for voice, 10,000 additional macro sites, 1,000 additional DAS, and 40,000 small cells. The new deployments will enhance our ability to offer best-in-class voice and data services for our customers. Our first field application for small cells took place in the fourth quarter of last year, with wide area deployments commencing the first quarter of this year. The small cells that we are currently deploying support UMTS and HSPA+, and next year intend to deploy small cells that are capable of supporting UMTS, HSPA+, LTE, in addition to Wi-Fi. By 2015, the small cells will be the dominant technology of choice used in our densification program. The future does indeed look bright for small cells. They can be used to expand coverage for hotspot applications and to increase overall network capacity. Small cells offer operators a system that is potentially more cost-effective than other solutions, allowing us to deploy in-building wireless solutions in business segments that were previously unattainable. We are very much in the early stages of deployment and currently utilize specially trained personnel to deploy the small cells, but due to their plug-and-play architecture, simple IP connectivity, and self-organizing architecture, a vision a day when we will be able to simply ship them to our enterprise customers and have their IT technical staff deploy them themselves. In the graph in the upper right-hand corner, you can see how the throughput of a typical macro BTS decreases with distance, using small cells can maintain a consistent level of performance throughout the coverage area. As the name implies, small cells are small, compact, and unobtrusive. They can be mounted on walls, ceilings, and even above drop-down ceilings. And in the image, the metro cell is shown with the omnidirectional antenna, which can be removed and replaced with directional or panel antennas. The RF output varies between 39 to 250 milliwatt, which is comparable to the power output of other indoor wireless solutions. The metro cell has a fast Ethernet interface, which can use the building's existing internet access for backhaul, and which can either be shared or dedicated. The self-configuring architecture reduces the time and cost of installation. Each metro cell can support 16 or 32 active devices and can support simultaneous and high-speed data sessions for each connected device. Each metro cell covers between 7,000 to 15,000 square feet, depending upon building layout and construction. Multiple metro cells can be deployed within a facility, allowing for seamless call handoff to and from other metro cells, and to and from the greater AT&T network. Just like a regular AT&T cell site, access is open to all users within range of the device. Now we're discussing backhauls. The metro cell has a fast Ethernet interface, which can use the building's existing infrastructure and a shared or dedicated internet connection. The diagram illustrates deploying the metro cell using shared network and shared backhaul. There are several benefits, that is, less cost, simplified site acquisition, and faster deployment. The disadvantages are the quality and performance of the system is dependent upon the customer's infrastructure, routers, switches, and the cables are maintained by the customer, and the operator has restricted visibility into the network, making it more difficult to manage as well as to maintain. This diagram illustrates deploying the metro cell using a dedicated network and backhaul. There are several benefits to this approach. The operator has more control over the network with much greater network visibility and the ability to maintain the system end-to-end. The disadvantages are more site acquisition requirements. For example, we're running cable to each and every metro cell, increased CapEx, OpEx, as well as longer deployment time. All that being said, we have been deploying our own LAN infrastructure to be able to manage and monitor end-to-end performance. So our preference would actually be to have a dedicated IP network as well as a dedicated IP backhaul. For the first field application that took place last fall, we wanted to evaluate the performance of small cells across a wide range of environments to include residential areas outdoors, an office campus environment, and an urban high-rise environment in New York City. For the outdoor environment, deployed the small cells in the residential area of Crystal Lake, Missouri. Crystal Lake Park is a small town located west of St. Louis, and due to the topography, had spotty coverage that was resolved once we deployed the 14 metro cells. After deploying the metro cells, the macro cell performance improved with an over 40% reduction in dropped calls. For the office campus environment, we deployed 12 metro cells in an office building in Waukesha, Wisconsin. We realized a 15% increase in network traffic and a reduction in the call drop rates once the metro cells were deployed. With ubiquitous wireless coverage throughout the facility, we have seen a significant increase in data traffic with more than 50,000 data sessions per day. You know the saying, if it works in New York City, then it'll work anywhere. We have deployed 20 metro cells for multiple enterprise customers in New York City. The picture illustrates the metro cell being deployed in the drop-down ceiling. In order to reduce the amount of time required to deploy the system, we use the customer's existing internet backhaul, or as described in the previous slide, we use the shared network, shared backhaul scenario. Last month, we made the announcement that AT&T is the official wireless provider for Walt Disney World Resort in Florida, as well as Disneyland Resort in California. AT&T will deploy more than 25 distributed antenna systems, 350 small cells, more than 40 repeaters, and an additional 10 cell sites to increase wireless capacity for their guests and cast members. In addition, AT&T will add free charging stations, which all wireless users visiting the resorts will be able to use to charge their devices. So looking into the future, AT&T will continue to groom and grow our network to provide the best platform for our customers. For the LTE upgrades at our macro sites to the deployment of small cells indoors and outdoors, it is all about AT&T customers having the best-in-class service. For 2013, one of our chairman's top priorities is for us to achieve the #1 brand in telecom, and the introduction of small cells in our network is a small step for our mobile subscribers, but a large step for AT&T. For our small cell roadmap, we have commercially deployed our femto cells, which support 4 simultaneous calls and is a perfect solution for home or small businesses. As we have already discussed, the metro cell can serve up to 32 simultaneous calls, and there are indoor and outdoor versions, and is ideal for commercial building, multi-dwelling units, retail, and outdoor environments. Then later, we will deploy multi-standard metro cells that will serve up to 64 simultaneous calls and supporting 3G, 4G, LTE, and Wi-Fi technologies, making it a perfect solution for large public venues. So to recap the lessons learned, small cells provide a coverage and capacity solution that augment the wireless carrier's mobile network. Macro base stations will continue to be the most efficient way to provide wireless service, with small cells being used in densely populated areas and to increase overall network capacity. Small cells offer operators a system that is potentially more cost-effective than other solutions, allowing us to deploy in-building wireless solutions in business segments that were previously unattainable. All that being said, cost-effective backhaul solutions are necessary for small cells to realize their full potential. So that really ends my presentation, and thank you again for your time.
Jim, Caroline.
Oh.
Yeah. Back to you, Caroline.
Sorry, I was muted. Sorry about that. I'm back now. Yes, sorry, I was just thanking Jim, saying it's always so enlightening and refreshing indeed to hear a presentation that's so geared to real-world experience. We seem to have talked about small cells for a lot of years, and sometimes rather theoretically, and that was, I think, addressed a lot of the issues, the challenges, and so on that we hear from all the operators that we talk to. That's reflected in a lot of questions that have come up. I'm trying to sort of group some that are on similar themes together so that we try and cover several of the topics that people are interested in together. And the first one, perhaps predictably, quite a few questions about backhaul. So, Jim, there was interest in what is the backhaul capacity for your small cell BTS, and with a fast Ethernet interface in particular. People are asking whether you see a need to scale beyond 100 megabits per second. and also specifically what the backhaul choices were that you used in Crystal Lake and Disney Park.
Let's see. The existing Metro cell can support HSPA+. And with that technology, the fast Ethernet interface is certainly more than capable of handling the backhaul traffic required for that interface. As we add additional technologies operating at much greater speed, for instance, Wi-Fi, LTE, eventually LTE-Advanced, those interfaces would dictate a much faster interface as well as place greater demands on their backhaul requirements. And actually, for the deployments, for our initial first field application deployments, we tried to use the existing the customer's existing backhaul in order to speed the deployment, so we can better understand its impact on the network and quicker time to market. So we utilize the customer's existing backhaul.
Excellent. And the other issue that always comes up, somewhat related, is of course power sources. And people are wondering what power options you're using, whether it's mainly utility or power over Ethernet, and whether that's a major challenge to Metro cell deployment.
Well, I mean, actually, AT&T's Antenna Solutions Group focuses on large public enterprises. And so they are primarily indoor deployments. And
yeah.
That being said, power is not an issue. The Metro cells can accept an AC power feed. They also support a PoE plus power, which is especially important for outdoor deployments, being able to have a centralized power resource.
A sort of more, perhaps a strategic question, I don't know, but AT&T is very high profile in this world, particularly in the standards bodies and the trades bodies, things like Wireless Broadband Alliance. So I wonder, I think it's been very instrumental, therefore, in trying to drive a broad ecosystem. But of course, the danger of having standards and low costs and so on is that you lose your cutting edge. I wonder where the balance is, and perhaps how much lead to market you feel you currently have over the bulk of the carriers who are still thinking about small cells.
Well, with the advent of the iPhone, and then subsequent to that, the Android devices, and then iPads, we have seen a tremendous load placed on our wireless network, and really are the tip of the spear where mobile wireless broadband is concerned in the United States. And with that being said, we're deploying any and all technologies in order to provide, a better wireless experience for our customers. And regarding the ecosystem, our role, we're the wireless operator, so we rely on our OEMs. We rely on our third-party integrators currently to deploy these systems, and so we need to have an ecosystem that is healthy and can be able to support that, because we certainly cannot do it ourselves.
Yeah, absolutely, that makes sense. One I quite like here, we talked a lot today about multi-mode small cells, and we saw that in the poll and some of what you've talked about. One of our audience is asking that you are obviously envisaging some Metro cells at least supporting 3G, 4G and Wi-Fi. If you only could pick two, which of those would you sacrifice? And I guess that leads on to the question of how critical Wi-Fi integration is to your strategy, and will that be, in the end, common to all your cells?
Well, that's almost not a fair question. I mean, we're currently deploying Metro cells which are capable of UMTS and HSPA+. Over 30% of our customers already have LTE devices, and we expect that to grow. Now, where the pain points, where the pressure points are on our network currently is on our 3G network. But as you know, as ubiquitous LTE coverage is made available, and in a large part due to Project Velocity IP, where we're deploying LTE on a much larger scale, we will see and continue to see more of our users utilize our LTE network to gain the greater speeds. And as we deploy advanced technologies like voice over LTE and the next version of LTE, so for instance LTE-Advanced, supporting carrier aggregation, which will allow us to better utilize both our contiguous as well as non-contiguous spectrum assets in order to provide our customers increased throughput. So with that being said, being the wireless operator, we are deploying 3G, we intend to deploy LTE with all of our future metro cells, and so that would continue to be our focus. So I'm not trying to walk away from Wi-Fi, but between the two, our customers expect and demand that they have ubiquitous, cellular coverage, and we need to ensure that would continue to occur.
Sure. So that's kind of first priority, and clearly AT&T has quite a lot of different pieces of spectrum that they're either using or trialing. Do you think, however, that you're going to need more spectrum, perhaps specifically for small cells in future, say in the 5-year period? We hear a lot about specific bands like 3.5 gig for small cells, and I wonder what your perspective on that is.
Well, as we know, wireless spectrum is and will always be a scarce resource. To the wireless operator, spectrum is like air, and without it, we cannot offer our customers the best mobile broadband experience. Small cells utilize many techniques to mitigate interference to the macro network, to include, utilizing directional antennas if necessary, advanced power control, self-configuring, self-optimizing network technology. And as I had mentioned earlier, macro base stations will continue to be the most efficient way to provide wireless service within, with small cells being used in densely populated areas and to increase overall network capacity. So to answer your question, would expect that any additional spectrum would be utilized by the overall network, that being, the macro as well as the small cells, in order to provide service for our customers. But if there's any additional available spectrum that would allow us to have spectrum specific to small cells, then that would be an ideal situation.
But any RF changes on the macro layer are going to have a significant impact on the metro layer, potentially.
It's all one large het net that needs to operate and coexist and work well together in order to succeed. And that's largely why we have been so instrumental at pushing and deploying small cells early on, is because we need to add that network capacity, largely to get in front of that data tsunami, so we can provide better service for our customers.
Absolutely. Turning now, quite a bunch of questions specifically about your indoor strategies, which of course is the main area of your group. First of all, a practical one. You referred to installing 12 to 20 enterprise cells, and one of the listeners is wondering how long it would typically take to install a system like that. I mean, they're largely plug it into the Ethernet backhaul as well as provided power. So it's possible to install multiple metro cells on a given day. Really, in looking at a network deployment, a lot of the work goes into the front end, and making, doing a proper system design, to ensure that the metro cells
can provide adequate coverage and capacity for the area at hand, but the actual mechanics of physically installing the metro cells, because they are so small, they only weigh 4 pounds. I mean, they're just literally just slightly larger than your existing Wi-Fi access point. And as an example, I placed an 8.5 by 11 sheet of paper on top of a metro cell, and it largely covered the metro cell, exclusive of the antennas, which are of course removable. So they are very small, and being small, we can hide and deploy them above false ceilings, mount them on the side of walls or poles, so that can be deployed without really affecting the aesthetics. And when you're looking at deploying small cells, whether it be a neutral host DAS system, Wi-Fi, or metro cells in a facility, a large public venue, aesthetics is extremely important. They for instance, like the hospitality industry, they have spent a great deal of money providing the customer experience, and what does the customer see when they walk into the lobby of the hotel, and what do they see when they walk down the hall and check into the room. And so to be able to quickly install a small solution that can largely be hidden from view is extremely important.
For sure. Also, a lot of listeners picked up on the comments about the neutral host DAS systems that you have, and the neutral host model in general, and that comes up a lot in our research as being an important element of small cells going forward. So I wonder how many carriers, other carriers, use your systems, and will it be a significant enhancement to the business case for DAS and small cells?
The answer is yes. The AT&T's Antenna Solutions Group was formed a little over 3.5 years ago, specifically to initially deploy neutral host DAS systems. The reason for that, I mean, when you look back over history, the initial in-building wireless systems were carrier specific, but the venue owners have realized that it is not acceptable to have 4 sets of antennas in the event that venue would require service from all 4 Tier 1 wireless operators in the United States. That's just simply not acceptable. So to be able to deploy a wireless infrastructure and then market and offer that system for, frankly, our competitors is essential. And the reason why that's essential is because not only do the venue owners demand that the solutions are neutral host, because they simply they can't afford the interruption, the downtime, and seeing so many different antennas, but it also allows us to deploy this technology and effectively lower our costs. And so when we go into a venue, in an ideal situation, we would go in with the other wireless operators working together for the initial deployment. But in the event that that's not possible or practical, our systems that we deploy are neutral host capable, and we do actively market those systems. We effectively treat the in-building wireless systems no differently than we do our macro cell site properties. And that's why having the AT&T Towers group is really kind of an essential piece of the equation.
Yeah. We've got time just for a couple more questions. I don't think we're going to get to everybody, sadly, but this is quite an interesting one. I think carriers normally position their metro cells as an augmentation for their macro layer for obvious reasons. But one question is wondering, over time, do you think the deployment of small cells will reduce the number of macro cells that AT&T will need to deploy, and is there a scenario where they would stop deploying or not deploy a macro cell because a metro cell rollout would suffice?
Well, I mean, when I went through the numbers for Project Velocity IP, that really does answer the question. I mean, with that initiative, we're planning on deploying an additional 10,000 macro cell sites, 1,000 distributed antenna systems, and over 40,000 small cells. So the macro cell site will always continue to be important to us because it is the most cost-effective way to cover a large area and a large number of users, with then small cells being used in areas, you know, pick an example of an office building. You know, maybe the macro provides excellent coverage within the facility, but you don't have coverage in the parking garage or in the basement. And so in that instance, just simply drop in a small cell, plug it into, you know, the building's existing internet, Ethernet, backhaul, and power, and voila, you have now ubiquitous cell coverage, even in areas that were previously unattainable from coverage from the macro layer. So the macro will continue to be very important for wireless operators worldwide.
Absolutely. And again, that echoes what we hear from all but a very small number of operators. You know, there are a few pure players and so on that are thinking differently, but it sounds very much mainstream thinking. Great. Well, we're a couple of minutes to the hour, and I'm aware that we've taxed Jim with a barrage of questions, so we do appreciate that, Jim, and all your interesting answers. And I apologise to people that have submitted questions that we haven't had time for, but I hope we'll be able to engage with you and help answer in future. I'm going to wind up the webinar now. Thank everybody very much for their time today. I know it's a very busy time of year, so we appreciate your attendance and hope that you found it very valuable. For any more information or engagement, all the details are there on your screen, so please contact us with further questions or information about the services. And of course, it just remains for me to say one more thank you to Jim Parker. Thank you so much for your presentation and your time today.
And thank you again for the invitation.
Goodbye, everybody.